Hello amazing people, my name is Shreya Kadavgaonkar and here's our another video. So today we are going to learn about the necessity of model selection. Why there is a need to select a model. So, choosing the right model is essential for optimal performance because model selection determines how well your algorithm will work with the given dataset and task. A robust selection process helps prevent issues like overfitting and underfitting to more reliable predictions. Good model selection enhances the ability of the model to generalize to new and unseen data. First, we will see what is a model selection. Model selection is the process of choosing the best model from a set of candidate algorithms. It involves balancing complexity, finding the right level of complexity so the model can learn patterns without being too simple or too complex. Next, optimizing objectives, aligning the model's performance with business goals, whether it's maximizing accuracy, minimizing cost, or other specific needs. We will see the reasons for model selection. First one is overfitting prevention. Overfitting occurs when a model learns not just the underlying patterns but also the noise in the training data. This results in model that performs well on the training set but poorly on new unseen data, that is test set. Signs of overfitting: high accuracy on the training set but poor performance on the test set. Solutions to overfitting: first one is cross validation, divides the dataset into multiple subsets to validate the model's performance on unseen data. Regularization: techniques like L1, L2 regularization help by penalizing overlay complex models, improving generalization. Fact that regularization can improve model accuracy by 15 to 20%. Second reason, underfitting avoidance. Underfitting happens when a model is too simple to capture the patterns in the data, meaning it cannot perform well even on the training set. Example of underfitting: using a linear model for non-linear data, predicting outcomes that follow a curved pattern. What are the solutions for this? Feature engineering, using complex models, and fact. Feature engineering: creating new features or transforming existing features can help the model better capture the data's complexity. Second, using complex models, moving to more complex models like decision trees, support vector machines, or neural networks may help. Then, fact. Feature engineering can increase model accuracy by 20 to 30%. Third reason, bias-variance tradeoff. The bias-variance tradeoff refers to the balance between two types of errors, that is, high bias and high variance. High bias occurs when the model makes overly simplistic assumptions and fails to capture the complexity of the data, that is, underfitting. And high variance occurs when the model is too sensitive to the training data, leading to overfitting and poor generalization to new data. Example of this can be decision trees often have high variance and overfit the data, while linear regression models can have high bias and underfit. Managing the trade-off: ensemble methods, random forest, gradient boosting combine multiple models to balance and variance. Cross-validation helps ensure that the model generalizes well to different subsets of data, reducing both bias and variance. Fourth reason can be computational efficiency. Resource intensive models. Complex models like deep neural networks require a lot of computational resources, example, powerful GPUs and large memory. Next, time constraints. Some models take a long time to train, making them unsuitable for real time or time sensitive applications. Next, Storage optimization. Model compression techniques like pruning or quantization can reduce the size of complex models by 50 to 75%, making them more efficient for deployment in resource constrained environments. There are some top interview questions that may be asked on the necessity of the model selection. First question can be asked on bias variance trade-off. You will likely be asked to explain this trade-off and its implications on model selection, performance, and generalization. Next, overfitting prevention. Interviewers may ask about strategies to avoid overfitting such as cross-validation, regularization, and early stopping. Next, cross-validation techniques. Expect questions about methods like k-fold, cross-validation, or stratified k-fold, which ensure models generalize well on different data splits. Next, choosing the right model. Be prepared to outline how you select a model based on the problem type, classification versus regression, data characteristics, size, feature types, and business needs. Next, L1 versus L2 regularization. You should know the difference. L1 regularization, that is lasso, encourages sparsity, driving some coefficients to zero, which is useful for feature selection. And L2 regularization, that is ridge, penalizes large coefficients but doesn't set them to zero, helping prevent overfitting. So thank you. This is your closing slide inviting questions from the audience to foster further discussion. If you have any questions, you can ask me in the comment sections. Thank you. Stay tuned. Please like, share and subscribe to my channel. See you in the next video.